Recall what I said in an earlier video, that if we just leave it all up to the program to take care of our variables, how and where they are stored in memory, and their memory addresses, if we want to skip all the hassle and just use the convenience of using a variable name, like just using the name x for our integer over here, then we would have to adhere to the rules of scope. However, if we start taking things into our own hands and digging into the details of where in memory our variables are living and poking around with memory addresses and all that, then we are basically taking things into our own hands, and so we could somewhat sneak around the rules of scope, and I show you how to do all that with pointers. However, if you think about it, we still didn't completely escape the limitations of scope. Variables and objects that I create in function A will only exist for as long as function A lives. So even though I go from function A to function B to function C, so for all that time, of course, function A isn't going to terminate yet, so the variables and objects that I created in function A will still live for as long as function B and function C and everything else is still working. However, again, we still did not escape completely the rules of scope. As soon as any function returns all of its local variables and pointers and objects, everything gets destroyed. Sometimes you'd like to create some objects and variables in function C or D, and you'd like these objects to continue living even after that function returned. Now that totally doesn't make sense according to everything we learned about scope until now. We know the ironclad rule that anything created inside of a function must disappear as soon as that function exits, as soon as that function returns. But yes, it is possible to have such a thing of creating stuff inside of some other function and then exiting that function. That function will now return and go back to where we came from in the calling function, and yet the variables we created in this other function will still exist even after we returned from this other function, breaking the rule that everything inside of local scope has to be destroyed. So, how in the world is this possible? Well, I'll show you, and this is where we really take over total control of variables, so the program will not at all be taking care of these variables. We have to take care of them ourselves, with the advantage that we completely bypass any rule of scope whatsoever for the reasons I will explain right now. If you'd like, you could think of it like as if there are two big storage rooms in memory for your program. One of these big storage rooms is the regular storage room where your program pretty much controls and takes care of all the memory and addresses and all that. And you can have pointers to those stuff in memory, which is what I demonstrated in the last couple of videos. But then there's this other storage room in memory where you will be taking care of everything and monitoring all the addresses and creating variables whenever you'd like, destroying them whenever you'd like, etc. So again, the first storage room is your program's domain, and that's where he will be taking care of creating variables and destroying them as soon as they go out of scope when we're supposed to destroy them. And yes, you can create pointers to those variables if you'd like, but don't forget that those variables have temporary lifetimes, and every variable declared in a function using the first memory storage room, which is letting the compiler, the program, take care of everything, will at some point be destroyed automatically by the program. The second storage room is the manual place where you will manually take care of stuff in memory. You yourself will create variables there, you will destroy them. No one will automatically delete stuff that you created there. You are totally in charge, which, as we will see, has the big advantage of not being limited to the rules of scope, but comes along with massive responsibility. Let's see how this can be done. How do we start doing stuff in this other storage room in memory? Well, let me show you an example right over here. All you gotta do is first create a pointer. The next thing you're gonna do is order your program to give you some memory space in this other storage room. The way this is done is by using the keyword new. The new keyword is the command to the program to supply you with some memory space in this other storage room that belongs to you. Well, how much storage space do we need? Well, it all depends on what we're going to put in that place in memory. Let's say I want to create a plain old integer variable. Well, if you want to make an integer variable on this other storage space, you will be using the new command, the new keyword, and the integer keyword followed by a semicolon. So again, what this does right over here is it creates space on this other storage room, just enough space for you to put one integer variable right over there. Now here's the difference between a regular variable and this variable that we created in the other storage room. Variables that you create in this other storage room, which by the way is known as the heap and arguably the free store, they do not have variable names. So we're not going to give this variable right over here a name because variables on the heap do not have names. What happens is this new keyword will create space in that memory place called the heap, and it will actually give us a pointer to a certain memory location, which is the exact place where our integer variable was now created. So actually this over here is considered an expression, and the expression that we get out of this is a memory address. A memory address in our storage room which now contains a integer variable. So of course all we have to do is grab this memory address and put it inside of some pointer, just like this. Right now our pointer that we created over here, which of course we made sure to make it of type integer because we want this pointer to point to a type of variable that's integer, like I explained. Right now this pointer will be pointing to a memory address in this other storage room that belongs to our control, it belongs to us, which now contains a brand new integer variable. Again, this integer variable does not have a name, it only has a memory address where it's located in memory. Our only way of accessing this variable is only by its memory address. No variable names, just like we've done until now with regular variables. We've been using the variable name. From now on, these variables that we create on the heap will never have variable names, and instead you will only have a memory address where this variable is located in this other storage room called the heap. So the only way we can control our variables on the heap is that as soon as we create our variables on the heap, we immediately assign the address that comes back from this new operation, and we stuff it inside of a pointer that we prepared from before. And of course, following the advice that I spoke of in the past few videos, we're going to do all of this in one single line, so that we don't leave our pointer over here all by itself without being first assigned to something. We'd like to right away assign it to something, and right over here we are assigning it the address of a memory location in this other storage room called the heap. And from this point forward, just like a regular pointer, you can dereference this pointer and start using it, and whatever you do to it, of course by dereferencing it, you will be affecting this variable, this integer that we just created on the heap. Right now, for example, I just gave our integer variable the number 9. Here I'm creating a variable inside of the regular storage room so I can give it a name and it will have the rules of scope, and giving it the number 9. Here I'm doing pretty much the same thing, creating an integer variable and giving it the number 9, but this is inside of a completely different storage room. Now please don't try this at home until you've watched another couple of videos.